In Chapter 2, there's a section on reviewing solutions. It's associated with Figure 2.7. Let's just jump into this directly by doing a few problems. The molecular mass of glucose is 180 grams per mole. What is the molarity of a 5% glucose solution? And again, the section you could check on is for this information is expressions of concentration on page 43, Figure 2.7, review solutions. Okay, so to solve this, first we have to understand the idea of what percent means. So in medicine and biology, percent is used in a kind of an unusual way. Usually percent means per 100 of something. So one person out of 100 likes anchovy pizzas, for example. That would be a 1%, right? 1 out of 100. So normally it's sort of like you have the same units, right, in the numerator and the denominator. One person out of 100 people. So it's a little bit unusual in medicine biology. They use the percent in kind of a non-standard way, in which they talk about percent solutions meaning grams per volume, okay? And the reason they can get away with this is, though it's not exactly precise, but it's very close. 1 gram is the weight of 1 milliliter, which is 1 cubic centimeter, at a certain temperature. Okay, so they're roughly equivalent, and so that's how we can say we can actually have different units in the numerator and the denominator. So we have grams per milliliter, for example. So a 5% solution would be 5 grams per 100 milliliters of solution. And just a quick side note, the term deciliter comes up a lot in medicine. So 100 milliliters is 1 deciliter, which is a tenth of a liter. So you'll see that a lot in your book. It comes up a lot in medicine. Molarity is the number of moles per liter, as you know from chemistry. So first we need to find the number of grams per liter. So we have 5 grams per 0.1 liter. Okay. So if we do the math, that's 50 grams per liter. Okay. And so we're going to have 50 grams per liter. And we want to know the original question was, what's the molarity of this 5% solution? So we need our conversion factor, which is the number of moles, the number of grams per 1 mole. So 1 mole is 180 grams for glucose. And so then we get this as our answer. We have 0.278 moles per liter. And of course, moles per liter can be expressed as a capital M, so 0.28 M as a capital M. And just if you go back here and note what's going on in this equation, you'll see the grams here are in the numerator, and then grams here are in the denominator, so they simply cancel out. And mole here is in the numerator, and liters are in the denominator, so that's why we have moles per liter. Okay, let's move on. To make a 1% KCl solution, you will use blank grams of potassium chloride. So go ahead and try that on your own. You could pause the video. Okay, now I'm going to go on and tell you how to do this. So to make a 1 liter of 1% KCl solution, you will use, and so what we need to do is, first of all, again, we have to interpret this 1%. So 1 gram per 100 milliliters. So that's going to be 10 grams per liter. So our answer is then 10 grams. You'd have 10 grams of KCl to 1 liter, and that would give you a 1% KCl solution. And the way actually you would practically make this up, whenever we talk about solutions, solution is the total volume. So that includes both the solvent and the solute. So in practical terms, the way you would do this is you'd have, you'd weigh out your KCl, in this case 10 grams. You'd add it to some purified water. and you'd have it a little bit less than 1 liter. You'd mix it, and then you'd use something like a volumetric flask to bring it exactly to 1 liter. And the reason you do this, you don't simply add, you don't measure them separately. In other words, you wouldn't add 10 grams to a separately measured out 1 liter of water, because now when you add the KCl, you'll actually have slightly more than 1 liter, and that would be incorrect. So you want it, the solution total volume should be exactly 1 liter. So again, you'd add the KCl to some to some water, mix it, and then you'd bring the volume up to exactly 1 liter using something like a volumetric flask. Okay, let's move on to how many grams of calcium chloride, which has a molecular weight of 110 daltons, do you need to make 300 milliliters of a 1 molar solution? Okay, so let's go through this. There's different ways to do this. So I'm not gonna impose my way of doing it. I mean, I'll tell you my way of doing it, but if you have there are equally good ways of reasoning this out. In fact, I originally did it a different way, but I did it this way. It's a little bit of a long route the way I did it right here, but I think it's very logical. So here's how I set it up. Your goal is to have a 1 molar solution, so I put that down here, 1 mole per liter. And that's going to equal, and here's our conversion factor. For calcium chloride, 1 mole is 110 grams. Now we want to know how many grams we need to make up a 300 milliliter solution. So I have that here. So X grams per 0.3 liters. And if you go through this and you look at the units, you notice we have moles per liter on this side. And on this side, we also have moles per liter, because moles are in the numerator here, and liters in the denominator. Grams simply cancels out, because grams are in the denominator here and in the numerator here, so they simply cancel out. So that's the first check you want to do, is to make sure your units all agree on both sides. Okay, so basically the way this equation is set up now, if we solve for x, we'll have our number of grams. So we'll have the solution. Okay, or the answer to our problem. So now what I've done is I've said, okay, let's just simply solve for x. And so the first thing I did was multiply both sides of the equation by 110 grams over 1 mole. Okay, so that cancels out on this side. So now we've got x grams divided by 1.3 liters equals 1 mole per liter multiplied by, now the inverse of this, which is 110 grams divided by 1 mole. We then, since we want to isolate x, I've now multiplied both sides of the equation by 0.3 liters, so that's out over here now. Now you'll notice in the last step here that moles cancel out. We have moles, mole in the numerator here, moles in the denominator here. Liters cancel out, and liters in the denominator here and in the numerator here. And so we're left with grams, which is what we want, right? The units should agree. So then we have essentially 110 grams multiplied by 0.3, so we get our answer, which is 33 grams. And then, of course, what you should always do is go back and check your answer. So we take 33 grams per the 300 milliliters, which is 0.3 liters. And then we want to know how many, we want to get back to this idea of 1 mole. So we put in our conversion factor, which is 1 mole per 110 grams, and we get our answer, which is 1 mole per liter. Right, so we've sort of back calculated, and we've confirmed that our answer is in fact correct. Okay, that's it for this quick short video on doing these calculations. Oh no, there's one more. Oh, sorry. There's another thing that really bothers students, which is this idea of equivalence. So let's go ahead and do a problem that has to do with equivalence. Normal blood calcium concentration is about 4.8 milliequivalents per liter. This concentration is the same as, and well, the correct answer is going to be in millimole over here. So let's see how you do this calculation. Go ahead if you want. You can go ahead and try and do the calculation on your own. If not, I'll show you in a second. So you can pause now at this point if you want to do the calculation on your own. All right, here's how you do the equation. So calculation. So equivalents are a unit used for ions, where one equivalent equals the molarity of the ion multiplied by the number of charges the ion carries. To convert from moles to equivalents, simply multiply the number of moles by the number of equivalents. 2 moles. So for example, so basically we're putting in a conversion factor. So if we have 1 mole of calcium chloride, we know that that's going to dissociate, and it will have two ions. Well, it doesn't dissociate, but it's equivalent. It has 2 charges, is what I should say. So it has double the equivalence, right? So 2 equivalents per 1 mole. So 1 mole of calcium would equal 2 equivalents of calcium. To convert from equivalents to moles, divide the number of equivalents by the number of equivalents per mole. So we're just going back the other way. So say you're given equivalents, 1 equivalent of calcium. Then we just put in the conversion factor, which is that 1 mole is going to be 2 equivalents. And so you get 0.5 moles. The concentration of ions in the blood are often reported in milliequivalents. So far we were talking about equivalents, but basically 1/1000th of an equivalent is a milliequivalent, and that's the unit you'll see most often in medical lab reports and so forth. So let's go back to our original problem. We have normal blood calcium concentration is about 4.8 milliequivalents per liter. This concentration is the same as, so you take 4.8 milliequivalents, you multiply it by the conversion factor, which is going to be 1 millimole of calcium. That's going to be equal to 2 milliequivalents. So you essentially just, you think about this, the numerator is equal to the denominator. So if you have, say, 2 numbers that are the same, all you're really doing is just multiplying by 1, right? You're always able to multiply one side of an equation by 1 without altering anything. Okay, so essentially we're going to get 4.8 divided by 2, and that's going to be 2.4 millimoles per liter. And you can write that here as 2.4 millimole with a capital M standing for moles per liter. And just to note, you can also look back at the units and make sure they make sense. So you notice here you have milliequivalents in the numerator. Here you have in the denominator. Those cancel out, and you're left with units of millimoles per liter, right? So millimoles in the numerator here divided by liters, which is the denominator. Okay, now that really is it for these equations. And in the background, there's someone wandering around, opening drawers, looking for candy and so forth. You want to say something? No? Okay, she's shaking her head. It's a little 8-year-old girl. She likes to draw pictures of mermaids.
6, not 8.
Oh, sorry. Her brother's 8. She's 6. She's 6. You're big, though. She's really tall for a 6-year-old. Okay, that's it for this video.